gives us range on one side, right? And then what do we do? What's the next thing? Divide by v squared? Yeah, I'm thinking, right? Gets rid of that, right? Now how do we get rid of sine? I need the real smart math people to tell us. Opposite of sine is inverse sine, right? Right? And that gets rid of sine. And then how do we get rid of the 2? Divide by 2, that's easy, right? Right? So this is our new formula here. Write this, whoops, that equals theta. It all equals 2. That's our new formula, okay? So let's try this. Let's now hit the target. Instead of hitting the target by putting it at 45 degrees, now we're going to hit it with some velocity that we know will hit it. The 23.03 was the smallest velocity, by the way, that would hit it. Okay, so let's hit it with something more robust. So let's stick in 50 for this, right? Now I'm going to stick in 50 because that's more fun. Okay, so 50 meters per second, try that. The range is still going to be 54.1, right? G is still going to be 9.8. So type exactly this into your calculator. You have to go second sine, right? So it's the second function of sine, right? And then you're going to have to go 9.8 times 54.1 divided by 50 squared, right parenthesis, divided by 2. Type exactly that into your calculator.
Go with 6.121.
Yeah, it's going to be a small angle, right? You guys get 6.121? All right, let's try this. Let's try this, okay? So our launch angle is now 6.121, yes? 2 or something like that, right? Okay, and then we decided that we were going to hit with 50, is that right? Yes. Okay, now this is, by the way, we're basically tilting the thing up like a little bit. We're basically shooting straight at it, right? But let's try this. This ought to hit it. There we go, yes. Okay, now, sure, yeah, it says direct hit, right? Okay, now let's try 90 minus 6.121. Try that. Do that right now. Go 90 minus 6.121. Because that angle should also hit. Remember that from the rocket lab? Yeah, you definitely need to be in degrees, yeah.
I'm going to go with 83.879.
Okay, here we go. So let's try it. 83 point what?
879.
879. All right. And then the same launch speed. Whoops, hit enter is 50. Are we ready for this? Yeah. This will be more fun. Off it goes. Yes, there we go. Right? It goes way up, it goes way down. Okay? So either one will hit, probably with the rocket lab. I don't know, we were probably using the low trajectory. Some of you were using the high. Okay? You see both these trajectories in football, don't you? Yeah. They both will get to, say, a receiver, but you never see a forward pass. You never see that high trajectory for a forward pass. Yeah, yeah. So why don't quarterbacks use the high trajectory? Why is it easier to get under the ball and intercept it? It takes way more time, doesn't it? It's got so much more hang time, and that's because it's got a ton of vertical velocity, correct? Vertical velocity dictates your hang time, right? So definitely a forward pass, unless you wanted to play 500. That'd be kind of fun, right? Okay. If you got Shaquille O'Neal as one of your receivers, that would work, right? Okay. Now, when do you see that high trajectory? You see that in football. And you already said it. When you punt it. And why do you use the high trajectory when you punt? More time for your guys to get down the field and beat the crap out of whoever tries to move the ball, right? Yeah, yeah?
Did you see Arion on Friday?
No.
He hurdled the hell out of this guy.
So he jumped him?
Yeah,
That is awesome. So that's the deal, right? And in fact, a punt that goes long and fast is actually a major tactical error. If you kick the ball low and fast, they do crazy stuff with it, right? So you see these strategies. This is actually what you've just done here is the second part of the lab, or third part of the lab you're going to do. So get out a sheet of paper right now, and on the top of it write Vernier Trajectories. Vernier. Oh, it's part of a lab.
So what is the name of it?
I'll write it on the board here. Vernier. All right. So what you're going to do with this lab is you're going to go. There's actually 3 challenges I want you to do. And the first one is challenge 1. Then I want you to do challenge 3, and then I want you to do challenge. Yeah, Vernier. It's Vernier, but we say Vernier around here. Trajectories. Okay, so let me show you what you got to do, because there were major questions about this. Like, it's not obvious, so. Indeed you are. Okay, yes, I'm going to quit. When you are done with the lab, please do quit out of the lab, otherwise it becomes this like hairball that sits on the computer. Okay, so you're going to quit out of it. On the desktop of the computer, when you log in, don't log in as yourself. I would need you to log in as physics is fun, just like it says on the monitors, right? On the desktop of that user, you'll see a little thing that says Vernier Trajectories. Open it up, okay? See this guy right here that looks like a little computer screen? There's lots of things called PRJX. Notice that you can see my extensions, but a lot of those computers back there, the extensions are hidden, okay? So, but this is the guy you want. It's the PRJX that looks like a little computer screen, not that guy, right? The other guy apparently does weird things to like the screen cursor, and we have to like log off and log on or something like that, right? And now we go back into 1990, right? This is 5 years before Windows 95, right? And press enter, there we go, right? And then there it is, and don't even dream of using your mouse because mice didn't exist yet, okay? What would a mouse be used for, right? So general instructions for challenges, nobody's ever read that in all the years we've owned this stuff, right? So go right to challenge 1, that's a cliff problem, right? So there's a cliff, hit enter to begin. Notice how it gives you the tantalizing possibility of using some angle other than 0. You're always going to use 0, so we're going to make this guy a pure cliff problem. 0, launch speed 25. 25 missed, okay? So how are you going to hit the target? Well, no guess and check, right? No guess and check. You need to deliver the parcel the first time so that they receive the benefits of the parcel right away, right? Because if you don't deliver it right away, then they might try to be gracious and give you back some aid parcels, right? Yeah. So what I want you to do for challenge 1, what I want you to do for this one is actually do this thing, right? Horizontal, vertical, and this is a cliff problem. You know how to solve these. You've solved many of them. What do we know for this cliff problem? Look at the screen, use your brain. What do we know? 0. Yeah, the initial vertical velocity is 0. Negative 9.8. This guy's 0. These guys will be the same whenever we find them. And that's what we want to find. That's what we type in as the velocity.
Wait, how do we know this one?
112.9.
Yeah, but we want to hit the target. So where's the target?
Oh, 133.
133.4. That is where? H. It's 133.9. Is that what it was? All right, that's good. 4? Okay, what is our vertical change in x? Look at the problem. Look at this thing. Look at the screen.
112.
The vertical. Is it 100? There we go. Negative 100.